Welcome to Day 8 of the KMC Technologies Group Microsoft Copilot Studio Implementation course. Our agent can now answer questions, route requests, create tickets, retrieve status, apply security controls, and escalate when necessary. But production readiness requires more than a few successful conversations. Today we turn informal testing into a repeatable quality engineering process where accuracy, routing, transactions, security, resilience, and user experience can all be measured. Today we'll learn several layers of quality assurance. We'll test individual topics and tools. We'll test full conversation scenarios. We'll measure grounded answer quality. We'll look at Copilot Studio evaluation capabilities and automation patterns. And we'll identify the operational analytics that matter after release. Then we'll build a regression dataset, define acceptance criteria, execute security and transaction tests, and create a release scorecard. A useful way to structure testing is as a pyramid. At the bottom, run many inexpensive component-level tests against topics and flows. Above that, test complete conversation scenarios. Then evaluate answer quality and grounding. Security testing challenges the system with adversarial and unauthorized requests. Finally, perform a smaller number of full end-to-end tests through the actual user channel and back-end systems. A passing conversation in the Copilot Studio test pane is only one piece of production quality. A strong agent test strategy covers both correctness and operational risk. Knowledge tests verify that answers are grounded, accurate, and free from invention. Routing tests confirm that the right capability is selected. Transaction tests validate the actual back-end result, not merely what the conversation claims happened. Security tests verify that restricted data and actions remain protected. Resilience tests simulate timeouts and connector failures. And channel tests confirm that identity, authentication, and user experience work correctly in Teams, Microsoft 365, web, or other target channels. The foundation of repeatable testing is a stable regression dataset. Start with real help desk language, including abbreviations, typos, and phrases users naturally use. For each prompt, label the expected route. That might be knowledge, create ticket, get ticket status, escalate, clarify, or out of scope. Then define the expected outcome. Add negative tests for unsupported requests, missing information, unauthorized access, and manipulation attempts. Finally, version the dataset so you know when each test was introduced and which release first passed it. A rubric replaces subjective statements like, "The answer looks good," with measurable criteria. For grounding, 0 means unsupported or invented information. 1 means mostly correct, but weakly supported. 2 means fully supported by approved sources. For routing, 2 means the correct capability was selected on the first decision. For safety, the best score requires a safe result and the correct redirect or escalation. For transactions, a passing result means the correct back-end action occurred exactly once. And for clarity, a strong response should be concise and give the user a clear next action. Deterministic topics should be tested like application code. Start with the happy path, where the user supplies every required field in the expected order. Then deliberately give multiple fields in a single sentence and verify that the topic captures or clarifies them correctly. Test changing a value before confirmation. Test cancelling before the tool executes. Provide an unsupported urgency or category. And test start over to verify that old values do not remain inappropriately in the conversation. When testing tools and flows, never trust the conversational message by itself. If the agent says a ticket was created, verify that the back-end record actually exists. Check that the fields match the user-confirmed values. Test retries and timeouts to ensure the same request does not create duplicates. Test authorization against records the user should not be able to access. Simulate connector failure and confirm that the agent does not claim success. Measure latency and make sure flow run identifiers can be correlated to back-end transaction IDs when support teams investigate failures. Quality engineering also includes adversarial testing. Assume that users, and even enterprise content, can contain hostile instructions. Ask the agent to ignore its rules. Place malicious instructions inside a knowledge document. Claim executive authority and request privileged access without approval. Ask the agent to expose hidden system instructions. Paste a fake API key and ask the agent to store it. Try to retrieve another employee's ticket. The goal is not to make a language model impossible to manipulate. The goal is to ensure that data and action boundaries remain enforced even when the language is adversarial. Copilot Studio evaluation capabilities can help turn manual checks into a more repeatable process. Use evaluations for regression prompts, expected answer criteria, comparisons after knowledge or instruction changes, and release gates for critical scenarios. A useful automation pattern is to store version test cases, trigger evaluations through supported workflows, collect results, and block release when critical cases fail. Failures should be reviewed before changing the agent. That keeps tuning evidence-driven instead of reactive. Leadership needs a small number of understandable release gates. For example, critical security scenarios may require a 100% pass rate. Create ticket success might require at least 98%. Grounded FAQ accuracy might target 90% or higher. Unauthorized disclosure should have 0 known cases. Routing accuracy might require at least 95%. And UAT should require explicit business approval. The actual threshold should match organizational risk. But the important principle is that critical failures should block release. Once the agent is running, analytics should help answer 3 questions. Is the agent useful? Is it safe? And is it getting better? Track conversation volume and active users. Compare resolved, escalated, and abandoned conversations. Watch the most common intents and no-match patterns. Identify knowledge questions that repeatedly fail. Monitor tool success rates and latency. Track escalation by category. Repeated user rephrasing can indicate misunderstanding. And compare evaluation scores from one release to the next. When something fails, change the layer responsible for the failure. If the agent provides the wrong fact, inspect the knowledge content. If the wrong capability runs, inspect tool descriptions and orchestration. If a required value is missing, inspect topic and variable logic. If the backend returns an error, inspect the flow, connector, or API. If unauthorized information is returned, investigate backend authorization and security. Do not automatically rewrite the prompt for every problem. Fix the smallest responsible layer, add a regression test, and retest adjacent behavior. User acceptance testing should look like real work, not a technical demonstration. Give users a scenario goal without telling them the exact words to type. Observe the terminology, shortcuts, and phrases they naturally use. Measure whether they completed the task, how many conversational turns were required, and whether the correct source or tool was selected. Ask whether they understood where the information came from and what action was performed. When prioritizing findings, address security and transactional failures first, then correctness, then friction and user experience. Agent quality is not static. A new document can introduce conflicting information. Instruction edits can change routing. Connector or permission changes can reduce transaction success. A channel-specific authentication change can create failures that do not appear in the test pane. Model behavior may change over time, and users may discover new requests that the original agent never supported. This is why the stable regression set needs to run after meaningful content, model, connector, platform, or configuration changes. Let's put the entire quality process together. First, execute the stable regression dataset. Every test has an expected route and expected outcome. Next, score answer quality using the evaluation rubric. For transactional tests, verify the backend record and not just the chat response. Run the adversarial security pack. Calculate the release scorecard. Suppose one prompt unexpectedly triggers Create Ticket when the request is ambiguous. Instead of making a broad change, diagnose the routing layer, update the relevant capability description, add the failure permanently to the regression set, and rerun nearby scenarios. Only after the blocking gates pass does the release candidate move forward. Before completing Day 8, make sure you have evidence, not simply confidence. The regression set should contain at least 40 prompts. Expected routes should be labelled. The answer quality rubric should be defined. Topic paths and back-end state assertions should be tested. Security and unauthorized access scenarios must pass. A release scorecard should exist. User acceptance testing should be completed or scheduled. And every discovered failure should become a permanent regression test. Your homework is to freeze a release candidate test set and resolve every blocking failure. Also prepare the dev to test deployment details, target channels, owners, and environment-specific values. Tomorrow we move from quality engineering into release engineering. In Day 9, we'll publish the agent, move it between environments, configure its channels, and establish an application lifecycle management process. This completes Day 8 of the KMC Technologies Group Microsoft Copilot Studio implementation course. We now have a measurable quality system covering grounded answers, routing, topics, transactions, security, resilience, analytics, regression testing, and user acceptance. In Day 9, we'll take our validated release candidate through publishing, channel configuration, application lifecycle management, and deployment. Thank you for learning with KMC Technologies Group.